Hey guys, Kenna here. Today we're going to take a look at the factors that increase and decrease air pollution, and we'll take a look at smog as well. Okay, so what are our essential questions for today? Number one, what are the factors that decrease air pollution? Number two, what are the factors that increase air pollution? And number three, what is smog and how are the two types of smog different? Now, before we jump in, I want to do a little bit of a review, go over the stuff we've gone over, especially some of the key pieces, before we start looking at these uh, topics. So, first, you have this picture here. Uh, I want you to kind of write down in your notes and think about what time of day was this likely taken, and why do you think that? I also want you to think about some people in the photo are wearing masks. Why do you think that is? I mean, now obviously for COVID, but this was actually taken pre-COVID. Okay. So why do you think they're wearing the masks? And then number three, I do or do not think the masks will protect the commuters because, and this is again, maybe a little different now than what you would have answered pre-COVID. So pause the video here, answer these three questions, and then we'll go ahead and move on. Okay. So I want you to keep the answers to those questions in mind as you go ahead and go through the rest of the presentation. Now, we've talked about a lot of different sources of air pollution, and we kind of grouped them into two categories: those that are natural air pollutants, dust, wildfires, volcanoes, plant pollen, etc., and then human activities like burning fossil fuels, using automobiles, electricity generation. Okay. And that when we look at these pollutants, whether they're natural or man made, there are two ways we can really classify them in terms of how directly they're put into the atmosphere. Primary pollutants are those that are emitted directly into the air from whatever the source is. Secondary pollutants, however, are chemicals formed from the primary pollutants when they go through some sort of chemical reaction in the atmosphere, okay, depending on what they are. So, again, we've got these two categories: primary and secondary air pollutants. So, air pollution in this case can come from a variety of different sources: human sources that are stationary, like a factory or a power plant, those that are mobile, like the automobile, the truck that you see here, or they can be from a natural source, like you see the volcano in the background. Regardless of which it is, a primary pollutant is going to be that which is directly emitted into the air. Okay, you can see a group of them there: carbon monoxide, carbon dioxide, sulfur dioxide, nitrous oxide, nitrogen dioxide, dinitrous oxide, VOCs, things like CH4, which is methane, and most of our hydrocarbons, and all of our suspended particles go into this category. However, some of those are going to go through a chemical reaction and they will produce our secondary pollutants. And these include our acids that we talked about in a previous class looking at acid deposition. Okay, so I want you to kind of keep those things in mind. So, our major outdoor air pollutants that we look at are our carbon oxides, our nitrogen oxides, and that produces nitric acid, remember, from chemical reactions with water vapor, sulfur dioxide, and sulfuric acid. So, there are your two combinations we look at for acid rain, rapid acid deposition. We have particulates, which is including our suspended particulate matter. We have ozone, which was beneficial up in the ozone layer, but here low level ozone is a problem. And then we have our VOCs, or our volatile organic compounds. These are your hydrocarbons, your methane, your benzene, your liquid solvents, these types of things. Okay, so those are the major pollutants we've been covering, we've been looking at, and we've been dealing with. So now we want to talk about what circumstances or what situations are going to increase or decrease the amount of air pollution. So let's start by looking at factors that decrease air pollution. The first one is heavier particles will tend to settle out as a result of gravity. So they're going to fall to the ground. Now, this could be acid deposition, depending on what the composition of those particles is, or you could see kind of this rain cloud, but it's not rain, it's not a liquid. What you're seeing come out of it is actual physical material. Okay. You can also have rain or snow, and these actually will help to clean the air. May not be as good for the water or the ground, but it definitely cleans the air out. So there's this kind of natural tendency to clean air pollution through rain, snow, and other forms of precipitation. Salty sea spray will also wash pollutants from the air, and this flows over the oceans. And so, even if you're not getting rain, this helps to keep the air pollution lower in the oceans as well. So, most of the heavier clouds of pollutants tend to stick over land. Winds will move and dilute pollutants by mixing them with the cleaner air. I know that's not ideal, but at least you don't have as much concentrated pollution in the air when you go ahead and see the wind moving it about. And then some of our pollutants are actually removed by chemical reactions in the atmosphere. Some of those are converted from one pollutant into another, but in other cases, they're converted into something that is less harmful. Okay. So if those are the factors that decrease air pollution, these natural systems that are trying to reduce and eliminate it, and if left alone, would clean the atmosphere over time, what are the factors that increase air pollution? Well, the first one is actually urban buildings because they reduce wind. And so there is less dilution of the material in the atmosphere. And so you see less removal of the pollutants because buildings get in the way in human made structures. Hills and mountains can do a similar thing. They can reduce airflow, leading to an increase in pollutants, especially in valleys, like we live here in the Willamette Valley. Okay. High temperatures promote the formation of photochemical smog. We'll talk more about smog later, but you get these things like inversion layers, and they trap this material down in that colder layer. Um, and so you end up with it stuck in these valleys. You have the emissions of VOCs in from certain trees and plants in urban areas can promote phytochemical smog. Okay. And so we can also start looking at what's known as the grasshopper effect. And the grasshopper effect essentially is air pollutants that are transported at higher altitudes from tropical and temperate areas to the Earth's poles. And so we talked a little bit about gyres and currents above the oceans and in the winds, but you can also see this in the upper levels of the atmosphere, actually moving some of these pollutants towards the poles as we get these convection cells, which go ahead and heat rises, cooler air sinks, and you kind of get this cyclical movement, which can move pollution to areas where it wouldn't otherwise necessarily be. The last one we've already talked about briefly, and I just wanted to bring it back up, and that's a temperature inversion. You start getting that warmer air kind of trapping cooler air below it, which is not what typically happens. Um, and that ends up causing a less mixing of the air. And you end up with this material that just kind of sits over the top, especially of cities. And this produces some of that dangerous smog. Okay. Now, we as humans are fortunate. Our respiratory system does offer some protection from air pollution. The hairs in your nose, the mucus in your upper respiratory system, sneezing, coughing, these are ways your body is trying to deal with things like smog and other air pollution. However, prolonged or acute exposure to air pollutants can break down these natural defenses. And so it's something your body can deal with in small doses, but if constantly exposed to large amounts of this over a long period of time, it can cause some really serious health effects. So I have a quick video here that's going to go over smog and help you better understand the science of smog, and then we'll go ahead and reconvene. Okay.
On July 26, 1943, Los Angeles was blanketed by a thick gas that stung people's eyes and blocked out the sun. Panicked residents believed their city had been attacked using chemical warfare. But the cloud wasn't an act of war. It was smog. A portmanteau of smoke and fog, the word smog was coined at the beginning of the 20th century to describe the thick gray haze that covered cities such as London, Glasgow, and Edinburgh. This industrial smog was known to form when smoke from coal-burning home stoves and factories combined with moisture in the air. But the smog behind the LA panic was different. It was yellowish with a chemical odor. Since the city didn't burn much coal, its cause would remain a mystery until a chemist named Ari Hagenschmidt identified two culprits: volatile organic compounds, or VOCs, and nitrogen oxides. VOCs are compounds that easily become vapors and may contain elements such as carbon, oxygen, hydrogen, chlorine, and sulfur. Some are naturally produced by plants and animals, but others come from man-made sources like solvents, paints, glues, and petroleum.
Meanwhile, the incomplete combustion of gas in motor vehicles releases nitrogen oxide.
That's what gives this type of smog its yellowish color. VOCs and nitrogen oxide react with sunlight to produce secondary pollutants called PANs and trophospheric, or ground-level ozone. PANs and ozone cause eye irritation and damage lung tissue. Both are key ingredients in photochemical smog, which is what had been plaguing LA. So why does smog affect some cities but not others? Both industrial and photochemical smog combine man-made pollution with local weather and geography. London's high humidity made it a prime location for industrial smog. Photochemical smog is strongest in urban areas with calm winds and dry, warm, sunny weather. The ultraviolet radiation from sunlight provides the energy necessary to break down molecules that contribute to smog formation. Cities surrounded by mountains, like LA, or lying in a basin, like Beijing, are also especially vulnerable to smog, since there's nowhere for it to dissipate. That's also partially due to a phenomenon known as temperature inversion, where instead of warm air continuously rising upward, a pollution-filled layer of air remains trapped near the Earth's surface by a slightly warmer layer above. Smog isn't just an aesthetic eyesore. Both forms of smog irritate the eyes, nose, and throat, exacerbate conditions like asthma and emphysema, and increase the risk of respiratory infections like bronchitis. Smog can be especially harmful to young children and older people, and exposure in pregnant women has been linked to low birth weight and potential birth defects. Secondary pollutants found in photochemical smog can damage and weaken crops and decrease yield, making them more susceptible to insects. Yet for decades, smog was seen as the inevitable price of civilization. Londoners had become accustomed to the notorious pea soup fog swirling over their streets until 1952, when the Great Smog of London shut down all transportation in the city for days and caused more than 4,000 respiratory deaths. As a result, the Clean Air Act of 1956 banned burning coal in certain areas of the city, leading to a massive reduction in smog. Similarly, regulations on vehicle emissions and gas content in the US reduced the volatile compounds in the air and smog levels along with them. Smog remains a major problem around the world. Countries like China and Poland that depend on coal for energy experience high levels of industrial smog. Photochemical smog and airborne particles from vehicle emissions affect many rapidly developing cities, from Mexico City and Santiago to New Delhi and Tehran. Governments have tried many methods to tackle it, such as banning cars from driving for days at a time. As more than half of the world's population crowds into cities, considering a shift to mass transit and away from fossil fuels may allow us to breathe easier.
The author of the TED Ed lesson you just viewed is a high school science teacher in Buffalo, New York, named Kim Preshaw.
Okay, so you get the basic idea of how smog works. So we have these two types of smog. We have industrial smog, which is a mix of sulfur dioxide, sulfuric acid, and particulates. This is very common in places like China, India, Ukraine, Czech Republic, Bulgaria, and Poland. And then you have the photochemical smog, which is a mix of primary and secondary pollutants, chemicals formed in light activated reactions in places like LA, Salt Lake City, Sydney, Sao Paulo, Bangkok, and Mexico City. And as we've seen, especially with the industrial smog, a big contributor to this is coal. So, industrial smog from coal consists of sulfur dioxide, sulfuric acid, and a variety of suspended solids. Urban industrial smog is not a major problem currently in more developed countries due to regulations about what they can burn and when they can burn it. But in places like China, India, Ukraine, Bulgaria, and Poland, they still have big problems with industrial smog. Okay, so India's pollution regulator threatens to shut down 14 coal-powered power plants. Nanoparticles produced from burning coal result in damage to mice lungs, suggest toxicity to humans. So there's a lot of research to link coal to a lot of health problems and to this industrialized smog. But countries like China rely heavily on coal to power their economy. In fact, 16 of the 20 most polluted cities in the world are in China. 92% of Chinese cities do not meet their own government's outdoor air quality standards as of 2013. So, when we start balancing all of these factors that increase and decrease the amount of air pollution, you start getting trapped in these little basins, like you see in Beijing, for example, and we have a problem. And if we don't stop burning coal, you're going to see it just higher and higher levels of this type of industrial smog. And that's going to decrease the health of the people who live in those areas. Now, photochemical smog is slightly different. It's a mixture of primary and secondary pollutants formed under the influence of ultraviolet radiation from the sun. And as we saw in the video, the process starts with the emission of nitrous oxides and VOCs. Once those are released into the atmosphere and exposed to sunlight, the chemicals react to form a mixture of pollutants, which includes that low level ozone, which remember is O3. And so our peaks are typically around late morning. So think about that picture you saw at the beginning of the notes and think about when you have the greatest amount of this photochemical smog. Is it photochemical smog? Is it industrial smog? You got to think about what times these are most likely to happen. Okay. There are definitely major health effects we need to keep in mind. Irritates the eyes and the respiratory tract. We can cause some damage to lung tissue. And remember that photochemical smog is much more common in cities with sunny climates and lots of automobiles. So we see it in places like LA, Salt Lake City, Sydney, Bangkok, and Mexico City. So, what can we do if we're seeing that we're having these higher levels of industrial or photochemical smog to reduce overall outdoor air pollution? And the answer is we need to really start looking at enacting, regulating, and enforcing laws and standards. We can strengthen our laws by prevention. Remember, prevention is so much better than treatment. This will reduce and control emissions, especially for cars and motorcycles. By setting stricter regulations for airports and reducing indoor air pollution, we can see lower levels of emissions in general. If we move to more green technologies, what can we do in terms of how much emissions we're producing? And then authorizing using emissions through trading. A popular thing to examine here too is what we call a cap and trade. So you have a fixed amount of total emissions that are allowed. They are apportioned out to different corporations who apply for them. If they don't use theirs, they can sell them to another company. So it allows some companies to pollute more than others do, but you're still setting this is the maximum amount of pollution without serious fines and taxes being accrued. Okay. So, something to keep in mind as you go ahead and go through this. And that's all I've got for you guys today. So, thanks for your time. Stay healthy, stay safe, and I'll talk to you soon. Take care. Bye bye.